Do you know what gravity is?
Yes.
You know what gravity is?
Mm-hmm.
Can you explain it?
The force of the Earth on objects that brings them down.
It is the force that pulls things towards the Earth.
Yes.
I don't know that Mr. Verrengia is going to like that definition, but...
So you say if I drop this ball, it will go towards the ground, yes?
Yes.
Good job, okay. So if I drop this ball, will it go towards the ground?
Yes.
Good. You know your physics. And if I drop them at the same time, what will happen?
They'll hit the ground at the same time.
What happens if I drop two objects of similar mass at the same time?
They fall at the same rate.
Okay. And what do you think will happen? Will they each hit the ground at the same time? Or no?
Depends.
It depends. Okay, so yes or no? Will they hit the ground at the same time?
Yes.
You think that's what will happen?
No, I lied. Yes.
What's your final answer?
They will hit the ground at the same time.
Good job. Good. You know your physics. That's good. If I drop this one straight down, but I throw that one over there, what will happen? What will hit the ground first?
That one.
The one that's moving.
Yeah.
I don't know.
You don't know. Okay. Well, let's figure out, shall we? You see that?
Uh-huh.
They hit the ground at the exact same time. Do you know why?
No.
Because gravity is still the same.
Yes. Like I said, there are similar weight and there's similar mass. But even though this one is in motion, gravity will pull it towards the center of the Earth at the same rate as the one that's not moving. And that's why they hit the ground at the same time. You understand the physics?
So listen, we've got the slinky here, and we want you to tell us what you think is going to happen if I hold it up from a distance and let go. Alright? It could be one of a couple things. You think that top's going to come down, bottom's going to come up, the whole thing's going to fall together, or it's going to come together, meet in the middle? What do you think is going to happen?
I think the bottom will be stationary. The top will come down into it, and then it'll fall together.
What do you think, Mr. Commissioner?
I'm done thinking about it. I think it'll come up a little ways.
It'll come up a little ways like that?
Yeah, the bottom will come up a little ways as the top is coming crashing down.
Uh-huh, and then it'll
Yeah.
meet together and crash down?
Yeah.
It's going to come together, meet in the middle. Together like that?
What? What the?
It's all the way down. No, it's all the way down. Now what?
So the reason why the slinky falls the way it does is the spring has tension in it from top to bottom. Gravity pulls down on the entire body at the same rate that the tension pulls the lower half up towards the top. These rates cancel each other out, and so the slinky appears to stay stationary in the air as the top comes down and pushes it all to the ground.
So now you see what happens when we drop a slinky from a high height. But what would happen if we changed it up a little bit? Most of you said that gravity is something that has an impact on what happens with the slinky when it's dropped. So what if we increase the mass on the bottom of the slinky by attaching a football? Let's see how this changes things. So it does the same thing, as you can see, and this is because even though the football adds more of a force of gravity at the bottom of the slinky, it also increases the tension in the slinky at the same rate. So the two forces are still counteracting each other, and so nothing happens.
What's up? Today I'm gonna show you a new physics trick. I'm gonna pull this tablecloth away without breaking anything. So try this and impress your family at the dinner table tonight. And the trick is, pull fast. And ta-da! And the reason that everything else remained on the table is because things at rest tend to stay at rest. And you might have heard of that before as inertia. But the real definition of inertia is the tendency to do nothing. Ooh, I like that. And inertia is why when the car stops, your body is still moving forward. Like ooh, or ooh. And if you don't have the seatbelt on, inertia can also save your life. Especially when someone attacks you with a hammer. The anvil on his chest saved Eric's life, but how does it do that? What's the physics behind it? If the anvil is not there, the hammer is going to accelerate into Eric's chest, and that is going to hurt him. But since the anvil has a large mass, the law of inertia tells us that it has a strong tendency to remain at rest.